So the topic that I will address today is related to network virtualization in the context of a data center and infrastructure as a service, with one idea to discuss, which is how to keep it simple, stupid. The funny thing is that my name is hidden by stupid here because of font issues. So, infrastructure as a service is largely considered as a key building block for, obviously, cloud services, whether they are for internal consumption by an operator or large enterprise, or cloud services for the public cloud, or variants like private or hybrid cloud, but also for NFV. OpenStack is considered as largely considered as a target foundation. It's not the only solution, but it's a solution that's got a lot of traction today. In this context in particular, network virtualization overlays that I will not detail today are really a key approach for scaling, automation, and better decoupling from hardware to address needs for connectivity for virtual machines, between virtual machines, between subnets in the data center, between the data center and networks outside the data center, so the internet or enterprise VPNs, and higher fine-grained services beyond connectivity, such as filtering, service chaining, or policing. More or less in this context, by and large, what we call SDN boils down to API-driven network virtualization overlays. So we have actually today many solutions that are available. Many of them have a good maturity and a good feature set. But we also see, when we look at them closely, which we obviously do as an operator, that they have a pretty significant complexity, and that the complexity of a deployment that uses both OpenStack and an SDN solution, and possibly additional tools for NFV, such as orchestration or VNF managers, these architectures have a significant complexity overall. So the question today that I want to discuss is how to keep it simple, stupid, given that we know that complexity is really a strong obstacle to agility and reliability. So, as I said, we accept it as a fact that in many contexts, in an increasing number of contexts, OpenStack has become the target platform for infrastructure as a service. So the question that we need to discuss is how to have IPA-driven overlays in OpenStack. And actually, we have two classes of solutions. One of them, which is very well known and that you've heard a lot about this week, is this architecture in which the network service, the network component of OpenStack, which is known as Neutron, delegate the work to an external solution, which is typically marketed as an SDN solution. This SDN solution being in itself a complete ecosystem of components with different components with different roles, with, in general, some kind of message bus or similar component to interconnect these components. Also with a persistency layer to make persistent all the data model objects. And obviously, in the end, some channel to drive the vSwitch running on the servers that host virtual machines. And sometimes including also a specific vSwitch. So this is a solution that we know well today because there are many solutions on the market and everybody's looking at them. But there is also another solution that's also actually used in production by some players, and that actually also works, in which a Neutron plugin is used to directly drive the vSwitch through the OpenStack message bus. So in this context, we don't have a whole ecosystem which is duplicated. This solution inherits the message bus, the persistency, the code base for deploying agents from OpenStack. It also inherits in terms of community, in terms of continuous integration processes, and so on. So this is an approach that today, despite not having the same feature set as SDN solutions, that has a significant advantage in terms of overall architectural simplicity. Actually, when we look at these two pictures, some people ask, why should we add an SDN solution to the picture? And it's actually an interesting question. And we know part of the reasons. One is that the business models of companies or communities building solutions is not always oriented toward open source. Or sometimes it has become open source but was not open source on day one. So it has been designed with the assumption that it should be separate from OpenStack, because if you are inside OpenStack, well, of course, you have to adopt an open source license. So that's an interesting reason. The second reason is that some vendors wanted to build products working not only with OpenStack, but also with other infrastructure as a service solutions, such as, well, CloudStack, if we look at the open source ecosystem, or possibly VMware too. Well, this reason today was certainly relevant a few years ago. Possibly it's still relevant in some areas today, but it's become largely less relevant. Well, because OpenStack has a lot of traction in the open source ecosystem, and because VMware has kept the integration of third-party solution closed. For some open source projects, typically labeled as SDN controller, there is another reason, which is that, well, the typical example that I have in mind is Open Daylight. There is an ambition to target use cases, many use cases, beyond the single use case of overlays for infrastructure as a service and for OpenStack. So that's also a good reason for building something outside OpenStack. A fourth reason is that vendors need to deliver products and want to differentiate their products from what is in mainline. So building something outside makes it easy to build arguments to say that the solution is different and better, which can be true or false, but it doesn't really matter, in fact, in this perspective. It's a motivation to build something outside OpenStack. The question that we can have is that among these reasons, is any of these reasons actually a technical reason? And in fact, well, reason 2, wanting to build something that works with OpenStack, but not only with OpenStack, is a technical reason, but as I said, it's faded out over the years. And if we look, oh, sorry, I had one left. I'll go back to this one afterward. So basically, if we look at these different reasons, we see that we don't have really a technical motivation to build a solution outside OpenStack. There are ecosystem motivations, community motivations, vendor motivations, marketing motivations, but not technical ones, not strong technical ones. The one point I skipped is the questions on how new work can be integrated into OpenStack, questions of how the community process scales, question of governance, relevant questions, but again, not technical questions. So if we don't have strong technical reasons to build something outside OpenStack, then the question that we can look at is, if we want to reduce complexity, then can we build a similar feature set as what we find in complex solutions inside OpenStack? So what are the options to make Neutron meet our requirements? So one requirement that we have is that we want, obviously, the virtual networks inside the data centers that connect virtual machines to virtual machines or virtual machines to bare metal, scalable and reliable. So there is an option to build overlays with Neutron with the ML2 plugin, the Open vSwitch or Linux-based drivers, possibly with some optimizations such as known as L2 POP. So these are very interesting solutions that are actually used in production and recommended by some OpenStack specialized companies. So this is an interesting solution. Another option that we think is interesting and which can actually leverage a well-known protocol for reliability and scaling Another option is to use BGP EVPN on compute nodes, and I will explain more on the next slide. If we look at interconnections with BGP VPNs, an option which again is interesting and which I will detail afterwards is to use BGP IP VPNs directly from the compute nodes. If we look at finer grained features such as service chaining, this is something that's somehow supported already in some OpenStack, in some project inside the OpenStack Foundation, in particular the group-based policy project, which has some support today already for what I would say simple service chaining. So it's already something that's in the work in the OpenStack community. And again, similarly as for neutron layer 2 networks, if we want this service chaining to be really flexible and scalable, an interesting option is to use the BGP VPN toolbox, IPVPNs and EVPNs, to establish inter-subnet and service chains, playing with root target import-export policies and route leaking between VPN instances. Now, if we look at the question of how to support bare metal, so bare metal servers and physical appliances, there are again different options to reuse the EVPN, BGP VPN control plane. Typically, we have today switches by vendors that already implement EVPN. We could also deploy lightweight BGP VPN stacks on white box switches, and we could drive them from Neutron. That's an option that we think is interesting. So a little focus on what I explained, the option on deploying BGP IP VPNs and EVPN on compute nodes. This is the architecture of a solution that we've been working on for a few years. So in this architecture, again, as I said, we try to avoid the complexity of a whole new ecosystem outside OpenStack, and we choose to collapse the controller function into Neutron. It doesn't mean that we put a lot of things into Neutron. In fact, in this perspective, the plugin that is added to Neutron is very lightweight. It drives through the OpenStack RPCs the installation of overlay endpoints, which means in this context, IPVPN verse and EVPN EVIs. These VPN instantiations are deployed on the servers running VMs, which are able to exchange routes between each other with a BGP route reflector, which is, well, a very well-known tool. If we look at the NCAP, in this context, we are pretty pragmatic. We use whatever works. So what is easy to use on today's vSwitches is VXLAN, possibly MPLS over GRE soon. Could be also MPLS over UDP. The point here being that we need an encapsulation that works based on implementations. We don't have to be religious about what we use. And since we also want to address the question of interconnects with VPNs outside the data center, we can establish BGP peerings toward ASBRs, use inter-AS options for VPNs, such as option B, and we can establish seamlessly the interconnections with VPNs outside the data center. So it can apply to plain connectivity, but it can also apply to service chaining between VPN sites and service functions deployed in the data center. So this architecture is, so it's a pretty detailed diagram. So you can have the feeling that there are many things, but in fact, all these components are extremely lightweight. The plugin above essentially allocates root targets to associate them to neutron networks. The neutron agent is just in charge of making the glue between the RPC bus and the BGP implementation on the compute node. The BGP implementation itself is pretty contained and lightweight. It's written in Python like the rest of OpenStack tools. It reuses existing work on BGP for Python, ExaBGP. It's just been extended to work for IPVPN and EVPN. And the vSwitch is consists in reusing existing vSwitches, whether the line external VXLAN implementation or the open vSwitch virtual switch. So a brief status of on implementation. Last year I had briefly explained the perspective behind this project with the announcement, if I dare say, of making the solution open source. So today the backpipe BGP component has been made open source. Well, actually since June last year. So as I said, it's a lightweight implementation of BGP VPNs. It has MPLS support through OVS. MPLS over GRE will come later. VXLAN support through the kernel implementation or through OVS. And it's actually, well, you can actually play with the code already since it's on GitHub. If we look now at OpenStack components, so the plugin and the agents, we have been working in the past months to push code for a BGP VPN interconnection API. So this goes beyond the use of the architecture that I mentioned. It also addresses a need that we strongly feel, which is a need for a unified API for BGP VPN interconnections. Today you have multiple controllers with different APIs. The idea is to propose an API that can be used and then drivers to delegate the calls to the different solutions. So we have today a base implementation and drivers will follow. The work on the API was done jointly with Nachi Ueno and Pedro Marquez from the Juniper Contrail team a while back. So the drivers, as I said, will include a driver for backpipe, which is the name of our solution, but not only. So code is already on GitHub. It's pretty recent, but there is already some code. Now for Neutron Layer 2 networks, we are writing a backpipe driver for Neutron ML2, the ML2 plugin. It's the GitHub project has been started. The StackForge OpenStack project, the associated StackForge OpenStack project has been started, but it's very recent. We don't have code on this repository yet. You'll have to wait for, I don't know, a few days or weeks, but it will be very soon. The code that we will publish is code that we have been running for already quite some time, but we have to refactor it to fit the new plugin decomposition pattern that's been adopted by the Neutron community. And we have also work coming to address needs for inter-subnet, policing, and service chaining. So, some conclusions. The question behind all of this is how do we assess the risk and drawbacks of complexity? We know that today, when deploying such kind of solutions, we have to make trade-offs between the feature set that we need and some level of dependence on complexity or vendors. The question that we need to address in the longer term is how to answer the question of whether all this complexity is acceptable or ideal or not. And the associated question, obviously, is what long-term move can we do to improve what we have today? And if we look at the different questions that I mentioned earlier, one of the motivations for building something outside of the OpenStack is sometimes the questions related to the OpenStack community and how it is able to process and to address new needs and new proposals. It's not that these are irrelevant questions. They are actually pretty relevant since the OpenStack community is complex, in particularly the Neutron community. But one thing that we need to think about is if trying to solve these issues outside OpenStack is the right approach. We may be just moving the issue rather than solving it by trying to solve it outside OpenStack. So we think there is value in trying to explore ways of fixing it inside OpenStack, addressing needs for operators of features such as scalable and reliable Neutron Layer 2 networks, needs for BGP VPN interconnection, need for service chaining. So we are exploring ways to address these needs inside OpenStack. So this is not what I've been talking about. Is not a product. But still, it's a serious exploration of an alternative of what we have today. So you are welcome to have a look at what we are proposing, play with it, and eventually contribute if you're interested. Keeping in mind that less is more. And I would actually welcome a question from the audience if there are any.
Okay, any questions? Thank you very much, Thomas.
Thank you.
Okay. So